right, so roughly half the people that registered, including all of those people that registered within the last 5 minutes, because my notifications have been flying off the wall. Um, Gonna go ahead and get started. Um, if you've been to my webinars before or my presentations that I've done at the various places, various SQL Saturdays and whatnot, I'm gonna give you a 15-second, history of me, a little bit of PowerPoint, and the rest of it's going to be all demos, so you can actually see things happen live. I'm Kevin Hill. I'm a senior DBA. I'm a one-trick pony. I tell people all the time. I know SQL Server DBA stuff really well. I'm not the best in the world. I'm not Paul Randall. I'm not Eric Darling. I'm not Brent Ozar. I learned from those guys. Um, I've met them all. They're very nice people. Um, but I do know quite a bit. I've been working with SQL Server since 6.5 if you count the little 3-week engagement I had to do. I started with 7.0 in 2000, and I've just downloaded the SQL 2025 public preview. I have not had a chance to install it yet to see what's changed and what is not. I have a feeling that's going to be an AI heavy centric type release with not a ton of extra stuff. But so this is SQL Server Indexes 101. The catchy marketing title was From Chaos to Control, and some of the things you learn in this might actually help some of your chaos become more controlled. I certainly hope so. This is aimed at, as are almost everything I write is aimed specifically at people that are stuck having to do DBA type things, whether that be installing SQL Server or maintenance, or in this case, getting indexes under control. And you're stuck with it because you don't have a DBA on staff, which makes perfect sense if you have one SQL Server that runs your ERP or your EMR system. Nobody needs to have that kind of salary for one server. And the sales pitch is that we do that for you on a fractional basis or even just an emergency retainer basis. So if your company needs that, great, give us a call. That's the pitch. So SQL Server Indexes 101. I'm picking specifically on, well, me now because I'm on the wrong screen and can't push the right buttons. Why indexes? Why do we even care? Speed. Indexes are all about speed, making queries go vroom, which is the sound my van makes when it goes down the road. Well, especially if I'm driving. If you've got, somebody asked a question similar to this, but if you've got, when do you need indexes? If you've got a 5-row table, you probably don't need one because that's going to all be on, probably going to be all on a few data pages, and SQL Server is going to read the whole thing into memory when it needs it. It's not going to care if you have indexes. Exceptions to everything I say exist. There are edge cases for everything in SQL Server. But that's the main reason, is to make queries go faster. If your queries don't go fast, your end users yell at you. People can't order stuff off your website. Bad things happen, and then somebody comes and yells at you some more. There you go. Makes end users happy. I wanted to do 3 different types of indexes, but I couldn't decide what that third one should be, so I broke the one of them out. Clustered indexes is the first thing we're going to talk about. This is where Jeff Moden's just going to sit over there and can, give nervous twitches. Non-clustered indexes, because those are the 2 most popular types and the most basic types that you'll see on any SQL Server you go to. I see them every single day, and I do index work every single day. And then third is more like 2.5. It's included columns on non-clustered indexes because that's a different aspect of a non-clustered. It deserves attention. And for those of you that have non-clustered indexes with 2 key columns and 47 includes, I see you in your select star queries. Stop it. So jumping right in, and we'll be working off the Stack Overflow database when we get to it. And actually, I think I'm working off the version that Brent puts out there. Actually, I know I am because that's the only thing we have. And there were some indexes in there, and I cleaned it up anyway. A clustered index, I hear this a lot. I've said this a lot previously. A clustered index is the data, is what I hear all the time. Some of you senior guys are going, no, it's not. More accurately, a clustered index is the definition that defines how the data is stored in the table itself. You can have a table of rows that doesn't have any indexes, including clustered ones, called a heap. That's the table. If you have a clustered index defined on it, and you go define one, and we will see this because I'm going to do it, and it's going to take like 2 minutes to do, it reorders the data, but it's not the data. effectively, it's kind of the same thing when you're not having a highly technical conversation around it. It's a DBA religious debate that we like to argue with each other about because it doesn't honestly matter. If you understand that clustered indexes are about ordering your data so that queries that need chunks of data can go better, that's really what you need to know. Obviously, if it's physical ordering, you can have exactly one clustered index. It can have more than one column in it, but you can't have five clustered indexes. So um, if you don't have a clustered index, it's a heap. It's just when I say heap, it's if you've got a notebook, a binder with the three rings, and you've got a bunch of pages in it, they're all in order, and you open up those rings, pick out the pages, and just fling them all over the room. Now you know what a heap looks like in SQL Server land. That's a bunch of pages just kind of all over the place. They're not ordered and they have pointers to each other. And SQL Server's working harder behind the scenes when you query those heaps or when you join to them with another table. There's just stuff that has to happen in the background that is harder, a little bit harder. And the various tools will report on that. So best practices, or I should say better practices, because best practices are being slowly beaten out of my vernacular. The key columns, which are the main columns, a lot of people have just an ID column with an identity specified on it, and they just get 1, 2, 3, 4, and that's their clustered index. There's times where that's appropriate, I'm sure, but the key columns should be the ones that you're using when you're doing range queries. And I'm going to give you an example here. If your most common query against whatever table is on date. Give me the last 30 days of whatever information. Or say it's on location because you've got 300 locations across the country or clinics or whatever. Give me everything from store 17. Maybe the store ID is a good candidate for a key column because when SQL Server's got to go look for those things that you're asking about, what's in your where clause, having them all together means less pages of index and table data are coming into memory to be read. That's really what indexes are trying to help you do is get to your data faster and bring less stuff into memory. Um, or you can have both store ID and date. Give me the sales data from store 17 for the last 90 days, and that could be an ad hoc query. It could be a regular report, whatever. That's what clustered indexes are best at doing. They're organizing the data because these types of queries exist. That's where I most commonly see them. 90 some odd percent of the queries that I see, or sorry, the clustered indexes that I see are just an integer or an ID number that's being shoved in there by an application or something like that. And there may be a field with it with a unique index on it, something like that. Or, cluster does not mean unique. A clustered primary key is unique, but those are two separate concepts. I mean, I'm not even going to go into primary keys. ID could be fine. Depends on what kind of data. If there's nothing that, really stands out as a good way to make your data be organized, that it actually benefits your queries, but you need something in there, you you want an ID column. For what it's worth, non-clustered indexes have your key columns, if you have a clustered index, included in them behind the scenes. So when you go make a non-clustered index, you don't need these two columns. They're already going to be there if you had a two-column clustered index, that is. ID could be great, it could be horrible. Some people use GUIDs, and Jeff has a whole presentation on that. Jeff Moden, go follow him, go find his stuff. All right, like I said, I don't spend a lot of time in the PowerPoint if I don't have to. Let's jump right in. I'm using, like I said, the Stack Overflow database. This is a 4-processor 16 or 32 gigs RAM. I think it's 32. I'm not really sure anymore. It's a modest box. So I've got a users table here because it came with it, and I've got a users 2. This one has a clustered index on the ID field. Users is the table, ID is the field. The users 2 is a heap. It's got nothing. It better have nothing because I killed it off earlier. Yeah, nothing. This is just raw data. So if we go and select the max creation date from these two, because there's no supporting index on creation date of any kind, because we only have one of these that has any index at all, and it's that clustered one on the users one, your users table. Clearly, this is taking long time just to find out the most recently created user. forget how long this takes. I want to say it's about 30 seconds for this to run. Yeah, give or take. And if you have this little gem, if you've never seen it and you're trying to measure how much things are happening, how long they're taking, how much actual reading is going on, turn this on, and for this entire session, it will stay on. You don't have to run it every time. But it gives you this joy down here, and it didn't do it. What happened? I didn't turn that on. That's what happened. And I also didn't turn on actual execution plans. Had all this working earlier, and then I restarted the box. So we're going to do that again. And what we're going to get in that messages tab is some things about compilation time, execution time, more importantly, reads. This table and these two queries, that number of logical reads, that's 573,000, which I'm going to generically refer to as 500,000 on through the rest of this demo. That many reads for get me one record of the max creation date is a lot. And it took a while, 3.5 seconds. We scroll down, it's the same in both places, slightly more here. There's some differences in the data in the two tables, but they're both ugly. The one that has a clustered index takes as long as the one that doesn't. Now, if we go run these guys, because there is an ID clustered index on users, that one came back very quickly. I don't know if you saw it. The other one did not. Let's look at the messages. Logical reads on the first one, 4 data pages. That's just about, I've seen 3 before, but that's about as low as you can get. Here's we still got 500,000 on the other one. The reason being, if you don't know how to read an execution plan, top to bottom, left or right to left. So the first one scanned the clustered index, but it knew it was on the ID. All it had to do was go down to the max one. It just went to the last row and read it. And here you go. What's really cool is if you this yellow thing that keeps popping up, if you press F4 on your keyboard, you get this properties window. This actually just sits there. It doesn't go. The subtree cost on this, which is actually the entire thing, 0.003. That's exceptionally small for a cost you would expect it to be. It's one row coming back on a very, very simple query. This exact same query without a clustered index that read the 500,000 pages, it did a table scan with this yellow bang or yellow double arrow. It used multiple processors. That's a parallelism indicator. Blah, 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 query optimizer, execution plan stuff. It had a cost of 443 because it scanned through the entire users to table, which is like 1.8 million rows, trying to find the max ID because it's just a heap. It doesn't know where anything is, so it had to look at every single page in that table and do some sorting and aggregations and things like that. And you see that right in here. So this took a long time. Something a little more common. Where did my create clustered index go? All right. This one. This is a much more common query. Coming from users 2, it shows you a bunch of rows, but it was still executing when it showed it to you. It gave me 151,000 rows really, really fast. It still read everything in the table. And still went parallel. It went quicker. And where did it go? Sometimes you have to click back and forth to get it to properly show up here. Still had this. The data was cached in memory already, so you didn't have to pull it off disk. So that helped a little bit. But this still took a little longer than I would have liked. How long did it take? Showing roughly 2.5 seconds to return 151 out of the 1.8 million records that are actually in there. So we're getting better, but this was your typical give me everything that happened within a month time frame. So this is on creation date. Right, so now on users 2, we're going to make the clustered index, which does not exist yet. We're going to turn this one on. This is going to take roughly 2 minutes to create. So we'll do that. And there's a question, are there any recommendations apart from the execution plan to create index? Yeah, SQL Server has built in a variety of dynamic management views that cover almost all the aspects of operation. They're basically metadata. One or more of them, there's always more than one, deal with actually index statistics, usage, missing indexes that would have helped queries go faster, that will give you a starting point. And I want you to hear me very carefully, everybody, when I say this. If you go find, Microsoft's version of the missing index report from Management Studio or something like Ozar, and I use all Ozar script, first responder kit scripts. If you go see those missing indexes and you run the create index statements blindly, you're going to have a bunch of garbage indexes and you're going to make a problem for yourself you didn't already have. The trick to it is to consolidate indexes and make the right ones. You don't want to make an index that's going to be used 4 times and be updated 4 million times every day. I'm going to go into some of that later. So reports like that, you have to go digging, find out what's being used, what's not being used. And honestly, it's going to be in the PowerPoint somewhere, but you need to be revisiting these things periodically. Periodically, that could be every week, it could be every month, once a year for you. I tend to, for my clients, go check them out once every 3 months, unless they start telling me the performance is going down. Then I go look for, stuff that's going wrong for whatever reason. Sometimes it's indexes, could be statistics are out of date. Those you should maintain. There were some questions that you people submitted when you signed up about rebuilding indexes. I'm in team, if you have enough memory, don't bother. Enough memory and SSDs. If you're still running hard drives, spinning hard drives, yeah, you're going to want to rebuild more often because that read-write head is going back and forth all over the place to read all the different pages that you need. SSDs don't have that problem, so they go much, much, much faster, and you just get almost no benefit from a rebuild in this day and age on current hardware. All right, my clustered index is done. Hooray. That took longer. It took an hour, or took 1:46 when I was testing earlier. You guys are looking at making it slow. All right, here's a good note. I'm not sure why I put it here. If you disable a clustered index, disable, not drop, the query becomes unusable. The table becomes unusable. It can't get there. It can't make. It looks for the index definition and says this is disabled. I can't even make you a plan. We're done. And if you do that in production, bonus points if you know what a CLM or an RGE are, or RGE is. Put those in the chat. Tell me what you think those are. And Jeff will tell me if anybody gets it right. He knows those terms. It's bad. You can drop a clustered index, and then you just go back to a heap. You're fine. Probably don't want to do that until you've done it. Don't do anything until you've tested it first. Anything I ever tell you, you test it first in case I'm wrong, because I'm human. I'm wrong sometimes. All right, so the same query that we ran earlier, now that we have a clustered index on the table, bang. Considerably fewer reads. A lot. Yes. Michael Despain says resume generating event. He is correct. But now somebody needs to tell me what a CLM is, because the CLM comes before the RGE. All right. So with the clustered index on the users to table, we got a whole lot fewer reads, and we just seeked because it was such a small subset of the overall table. It called it a seek, went into that index specifically. In here it says users2.cx creation date. Grabbed my rows and tossed them out the door. This went serial too. There's no yellow circle with the 2 arrows. So we're down to, went from 400 something cost down to 3 point something. This system is set to anything under 50 goes serial. So I used 1 CPU instead of tying up all 4 or 8 or whatever I've got 4 on this one. The benefit of that is not that you just used less CPU, but you freed up CPUs for other queries. So everything in SQL Server is dependent on everything else behaving. It's a shared resource across multiple databases, multiple queries, multiple tables. The more resources you can free up by good coding and intelligent decisions, the bigger the hero you look like when they come back and go, the 30-minute query is running in 4 seconds now. And now you're awesome and everybody loves you. Going back to the slide deck now. I'm glad I put that note in there for myself. As soon as I find the PowerPoint button, there it is. All right. So clustered indexes are fairly basic. They define the order of the data, like a white pages. If you're old like me and you remember what white pages are to look up phone numbers and addresses and all that. Last name, first name, address, phone number. In that order, and you really can't change it. Non-clustered indexes. This is where I make my money. I go in every day and fix these. None of my clients have a DBA. They come to me specifically because they don't have DBAs. They have very smart developers that know indexes are good. They have sysadmins that know how to back up databases, but they don't have anybody that knows all these pieces and parts. We can set up backups. We can tune the server well, but we do indexing work for every single client. They are a separate thing that takes up space on disk. They are, think of it, don't at me on this, think of it as a small subset of the table, and that's going to be in here somewhere. If you make a two-column clustered index, non-clustered index, you basically have created a new thing that has those two columns, and there's some statistics on it that Query Optimizer can go there instead of to the table to make your query come back faster. It does take up space in the database, on the hard drive, in your backups. When they're used or maintained, they're taking up memory space, and they go through your log files. So the right number for your situation and your workload is the right number of indexes. The limit is 999 non-clustered indexes. It's not a goal. It's a limit. Don't do that. If you have 999 on your table, don't call me. I'm gonna knock off 800 of them just right out the door because I can almost guarantee you. And Rhonda, you're correct. Career limiting move is what a CLM stands for. Well done. Yeah, if you make a career limiting move, you probably ought to go ahead and start the resume generation, um, or get really smart and never do it again. Raise your hand, say you screwed up, admit it, own it, move on. All right, 999. I've heard of that. I don't think I've ever seen it. The most I've ever seen, I think, is probably 204 or something on a table that was 400 or 500 columns wide, which is also ridiculous. Somebody committed spreadsheet upon their database. I think it's against DBA law to not talk about B trees when you talk about indexes. Uh, my friend Sebastian Miney, talked to him today. He approved me putting this image and a link to his page. That's why there's a link there. But Sequility, I don't know if that's how you say it, Sequility.net. He's a DBA. I think he's got a couple of other people working with him. He is brilliant. The B tree, a lot of people think it stands for binary tree. He's actually got in this article, the people that created the indexing B tree they left it just vague, just B tree, because binary tree was actually something else 40 years ago that they were trying to find a better way to do indexing type things. So I'm going to call it the Boeing tree. So because those guys both worked for Boeing at the time. Yes, the airplane place coined a term for us. So go to his site if you want to read really in depth on how non-clustered indexes are stored and why they seek. Essentially, you're following a path from top to bottom, following the arrows and getting into smaller and smaller chunks of data as you go. It's as technical as I'm going to get with it. Let's do a demo again or another. All right, so select display name from users where display name equals Kevin 3 and F. Bonus points if anybody knows who that guy is. You're all going to get the points because it's me. Internal and external fragmentation. I will try to get to that. All right. This one completed pretty quickly. Display name from users, which is the first table. We go here, 500,000 rows or 500,000 pages. My bad. And then we look at the execution plan. That query, it only took 2 seconds, but it went parallel, read everything, and had a cost of 435. Again, all the data is cached right here. It's all in memory because I've got enough memory to cache that table. So love this green thing right here. This is a missing index hint or request or observation. Let's call it that, a missing index observation. This is SQL Server saying there was no exact index that matched this query perfectly. If this is a much bigger query and there were 4 of these, it would show me 1 right there. You would need to go not to missing index details, but to show execution plan and find the missing index section here, and it will show you all of the ones missing from that overall query. That's as deep as into execution plans as I'm going to go. This is a suggestion, a starting point for you to look at because you might already have an index that is satisfying what this one is saying it wants. So take that green stuff as with a grain of salt and go, huh, let me go verify that I already have something doing that work. Don't just blindly create these. I'm going to show you how people do it, and then they come to me for help when they've messed it up. They do missing index details. This is here. They highlight this and they hit execute. I know because I see this index name all the time, or underscore DTA underscore something, where they ran the database tuning advisor or whatever it's called, and just took the suggestions without understanding what you guys are starting to understand from today's lesson. So that's what that ran. 400 cost is pretty high. Magnify any of these things times, thousands of executions a second on a big system or millions a day or whatever, and things get really, really ugly really quick if you have poorly indexed tables. So we're going to drop an index on here. It takes roughly 30 seconds on, previous executions. It's going to be just, I preface with non-clustered. You don't have to have the word non-clustered here, but on Stack Overflow, the users table, not users two, on the display name column. That's it. One column index because that's what it asked for. And when that's done, we'll run it again. Okay, internal, external fragmentation. Internal is things being out of order and having a bunch of empty empty space in the pages that your index is taking up. Fragmentation externally, and I'm going to get this not wrong, don't at me, is things that are physical fragmentation all over the drive. So if you've got limited drive space and there's nothing you can do about it, you can't add drives, you're pushing the limits anyway, that's where you're going to probably have to do some rebuilds, even on SSDs. If it can squish, 10,000 index pages into 1,000, but that's going to be temporary. If you've got an active system, that's going to be very temporary. Logical fragmentation is internal with empty pages, and it's kind of a squishy little definition. There's a better definition out there, and it's just eluding me today for some reason. Okay, so our non-clustered index is built. We're going to rerun that query. Bang, done. Not 500,000. That's awesome. And execution plan, it went right to it. Index seek non-clustered on the NC display name index. It went straight to the index, got everything it needed, which was just the one column, one row, because Kevin 3NF, there's only one user with that name, and it's me. You can have a username of John, and you'll have to, put other things in there if your name is John and you want to find your stuff. But this went from whatever it was, 400 and something on the cost, to back down to 0.003. And I love it that Microsoft actually calls your query trivial, like it's unimportant. No, it was just simple. That's all that means. Customers have gotten offended when I called their stuff trivial before. I had to explain it to them, and I don't know if they ever forgave me. All right, so we went from 400 cost reading everything into memory for the whole table to find me to bang. There, I don't know if you could hear the snap or not. That's the benefit. Now multiply this times a bunch of people logging in just constantly to your very, very busy sales page or checkout, or people logging into your social media platform that you're the backend for. That matters. That matters a lot. So, well, let's do this. We've added a column here. We're going to add in the ID. Now, I said something earlier about IDs and clustered indexes and stuff like that. I'm going to run this, and it's going to give me exactly the same thing, because ID is my clustered index. And I said earlier, the clustered index column or columns, are automatically included in your non-clustered index. So this was already there hiding in the background. It gave it to me anyway. It wasn't in the index where you can see if you open up the index and look at it like this. There's a display name and nothing else there. You can't see that ID column is there. It's a hidden column. Brent calls it a secret column in his SP Blitz index tool. I reference Brent Ozar a lot because, again, we use their tools all the time. The Brent Ozar Unlimited, whatever it's called. All right. So now that we've talked about that, let's put reputation in there, which is not part of my clustered index, so it's not in there. What's going to happen? You have 5 seconds to say it in the chat. 1, 2, 3, 4, 5. I did hit start on that. Good. I could tell. My reputation is 108. I don't know who said it, but key lookup is correct. 8 logical reads this time instead of 4, so we had to read a little bit more pages, but 4 pages is nothing at 8K per page. But What it did, it went and got me out of there, but it didn't know my reputation. So it went back to the table, which it calls the primary key. In this case, is the PK user's ID is clustered. It went to the clustered index or to the table to get my reputation, but it used that ID column that is already in this one to go to this one and pull that one number out or that one value out, the big 4 6 whatever number it is that is unique to me. So this is still a super fast query, even though it's got the key lookup, but it was 0.003. Now it's 0.009. That's an exceptionally small number until you multiply it by millions. It tripled the time or tripled the cost. To you and me as humans, that's nothing. It still was basically instant, but in computer lands, that could add up in a hurry when you have key lookups. It's very common for me to see what I'm seeing right here. If you look at key lookup right under the users where it says cost 67%, that's a very vague, fluffy number. It's not an exact science at all. Um, but I very frequently see, oh, look, there's a key lookup, and I love this part of the properties window. It says, well, great. What did you look up? I looked up the reputation column, bro. Oh, I can work with that. Let me see if I can get rid of this key lookup by tweaking indexes a little bit. This is where stuff gets really fun. Uh, because it's very common for something. We released some new functionality to our app last night, and now things are slow. It's because there was a select ABC query that was doing just fine using the index on A, B, and C. The developers needed to, for whatever reason, add column D to that query, and column D is not in the index. So now it's going back to the table, getting the D value and bringing it in millions of times an hour. So when the queries change, as they should in an active development environment on whatever it is that you work on, they probably shouldn't change all that much in a third-party app, but that's a very common thing to do. We're going to enhance the query. We're going to add a new field that customers have asked for. There you go. So let's go down here. We're going to make a display name and reputation column or index, non-clustered index. Aha, that'll fix that. We'll show those developers that we know how to index. They know how to develop and we know how to index. We're both great. We love each other. We have lunch together. It's all good. I'm a big proponent of DBAs and developers actually being nice to each other. And I'm a big opponent of DBAs sitting back saying, it depends and nothing else. You can say it depends, but just follow up with what it depends on. Let's create friendships between the different silos. Clearly, I'm stalling for time while this index creates. Again, probably 40 seconds, give or take, or 31. Cool. All right, so that's created. Same query. Let's see what happens. Same result. Back down to 4 pages. That's good. Look at there. Look at that. It's gone. The key lookup is gone. If you see RID lookup, that's basically the same as a key lookup. It's just looking up in a table that doesn't have a clustered index on it, or a RID lookup if that's what you're used to calling it. And also, check this out. We're back down to 0.03. So we created a new index that has 2 columns in it. So we've added space to or added substance to the database. We've taken up some more disk space, et cetera, et cetera. If this thing runs a million times a day, it's worth it. If it runs once, if it runs once a month, maybe not. Most people will wait 30 seconds for a once a month query. They won't wait 30 seconds for your app to time out or finish. I guarantee you. On Facebook, maybe you wait 5 seconds. Everything else, humans get a little irritated when a web page doesn't come back in a second or two on a good connection. So that's the kind of time frame we deal with now. All right, so we got rid of the key lookup. Problem is we have 2 indexes that have some overlapping functionality. It's borderline or near duplicates. They're close. They're not exactly the same. I mean, I could make 2 indexes that have the same 2. I could make 100 indexes that have the same 2 columns in them, or 999 if I was just, trying to really hurt myself. Let's kill off the one that is just display name. Actually, we're just going to disable it. I'm not going to delete it. I like to disable because somebody mentioned when they signed up, or somebody said something about hints. Maybe it was in the chat. If I disable an index and some query that nobody knew was still out there is using that index as a table hint or a query hint, that query is going to fail the next time it runs if that index is gone. It'll fail if it's disabled too, but at least I can right click and rebuild in a hurry. Because when this is gone or disabled, let me go back over here and refresh my indexes. It doesn't even show right there that it's disabled, but there it is. Somebody comes screaming at me like, the thing is broken. I can just right click here and rebuild right in the GUI. I don't even have to pull out the alter index rebuild code. Somebody else can do this. A help desk person can do this, doesn't know SQL Server. That's happened to me. I've been doing this a long time. So let's run this thing again. Now, previously, it used different index and whatnot. Let's make sure this still works. 4 pages, still using the same thing that it was. So we didn't hurt anything by disabling that one. That's what I expected. Clarifying something I said earlier, non-clustered indexes are basically a subset of the table. And as what we've done with them so far, using just key columns in the non-clustered index, we'll get to includes in a little bit, that gathers statistics when they're created, a full set of statistics, and that's what the optimizer uses to determine what index to use or not use, how many resources, the CPU, memory, all that, to estimate and create a plan. And that's what these are over here. This subtree cost is a combination of the resources and time, whatever that's going to be used, number of rows. It all comes into it to give a complexity number. It's like kind of how I explain it to my clients. How complex is this query? If it's got 5,000 cost, it's more complex than this 0.003. Obviously, it's probably got tons of tables, lots of joins, probably some functions and whatnot, which is the much more common, these simple queries you're seeing, they don't happen all that often. Not in my world anyway. But they're a subset of the tables. That's why you want to be judicious with them. 999 indexes that are adding space to your database is nuts. If there's two that both work, like if I'm doing a display name and I've got an index on display name and another one on display name and reputation, it's probably going to use the one that has just display name. It's looking for the closest it can get to exactly what it needs. But now that I've disabled the display name one, I might see a index recommendation to create that if I were to run just the display name, because there's not an exact match. So that's where you can get in trouble with the missing index recommendations, is exact matches don't always have to be there. And that's what this is about. It will usually, there are weird cases around dates and things like that, when the date was created, of if it's got multiple ones, which one is it going to use? If it could use any of them, it doesn't always go to the smallest one, but that's generally how it works. We could do an include rather than having it as a key column. But let's go talk about includes first before we actually start showing them off. They're cool, but they can go really, really bad too. All right. Included columns on a non-clustered index. You cannot include on a clustered index. That's why I wrote it that way. I actually had a religious debate with myself about should I put this in there, and the smart part of my brain said, yeah, duh, this needs to be there. It's common. This is essentially what you're trying to do with an include, is avoid key lookups, because as we saw earlier, the key lookup tripled the amount of time. It went from 0.003 to 0.009, just having to go get that one value out of the table, because it's essentially joining itself to another table to go get it, blah, blah, blah. It makes things go faster, or makes things go for them. If you put all of the columns in there, because you never want to do a key lookup, you've effectively made a copy of the table, because now I've seen some of your tables. You've got 200 columns in there. A 200 column index, it may not even be allowed. I don't know what the upper limit on number of columns in an index is. It's big. I know that because I've seen some of your indexes too. Putting all of that in there probably means if you've got a missing index request or recommendation that has all your columns, somebody's doing select star from table, or from 7 tables, join them all together, whatever. That select star is saying, give me all the columns. All you developers know that. DBAs know it too. That's rarely a good idea. That's when I bounce back over the developers and ask them, do you really need all the columns? Or was it just simple to do it that way and you were in a hurry because managers were yelling at you? Pointy-haired boss was telling you to do it that way. Bonus points for the pointy-haired boss. But that's rarely going to be a good solution unless it's like a 4-column table, and it's got to be done a couple of different ways because you've got 2 competing queries that ask for something in reverse order. There's weird cases where that makes sense, but never on a big, huge table like that. This is not exactly right. But when you've got select column list from table where stuff equals stuff, or where some column equals some value. The key columns are going to be in your where, the things that are in your where clause. To some degree, your join columns are going to be important as well. Things that are just in the select don't need to be a key column. They can just be there hanging out in the select. They can be includes, and everything will be fine. That keeps the key lookup from happening. But which index is used depends on what things are in your key columns and very often what order they're in or the selectivity they're in. Modern versions of SQL Server are getting better at kind of reworking things behind the scenes, so the order doesn't matter as much as it used to, and I can't tell you when that started changing or the nuts and bolts behind it. So again, another religious debate that tends to morph more over time. So I'm going to probably send the PowerPoint out, or put it in the up on YouTube at some point, this video. So there's you can just Google that if you want to go look and see specifically stuff about included columns from the Microsoft site. Back to the demos. Well, I'm trying to find the buttons to click here. Can you please explain if there are disadvantages of configuring fill factor greater than 90%? I do 100%. I do 100%. People that like a low fill factor of how full is the index page is what that means, of 50, 60, 70%, what they're doing essentially is they're leaving room for stuff to be added to it, which is saying, I'm trying to avoid page splits. That's really what's happening. In the modern era of SSD and instant file initialization, which is a Windows thing that SQL Server can use, page splits are nothing. So I slam them full. When I have to rebuild, I do it 100%. But when I create them, I do it at 100% too. If I make it 80%, I just said, here, waste 20% of my drive space, or 20% of add 20% to the space, and also take up 20% more memory every time I look at this index than I should. So anything under 100% on SSDs doesn't make any sense in my brain. Bring that up. If you want to argue on that one, go find one of my index posts on LinkedIn. We can do it there. We'll have that debate in public. And if I'm wrong, I'm wrong. I'll admit it. I'm cool with that. I'm wrong regularly. Or so people tell me. Ha! All right. Included columns. We've got a new column in here. Location. It's highlighted in blue because apparently it's a SQL Server reserved keyword. I don't care. But selecting these three, we've not touched location at all, so you know it's not in an index yet. So we're going to get this silliness. 8 here. That's not too bad, but we've reintroduced the key lookup, and it's probably going to be the same low level costs. Yeah, this one is 0.9. So, but we've got a key lookup back in there. Fantastic. Super happy about that. Not really. So what we're going to do, and the syntax is a little different here than what we've been seeing so far. I do it this way. My key column here, my other key column here, which matches these guys right here. And I just use includes because I might have 5 or 6 includes. I'm not going to list all of those out because I'm lazy. And I'm sure there's a character limitation to how long an index name can be at some point. But it's create index on table. This one, ascending, descending, whatever. Obviously, I generated that one from the GUI because I don't type in ascending and descending. Include the location column. Difference between having the include here versus in the key columns is you're not going to get any statistics on location. You don't need them because the optimizer is not going to use any statistics that were there because it's just in the select list. It's just bringing it along. It's already made its decision to go to the movies, and then suddenly it's told, oh, I got to bring my little brother to the movies with me. You don't really plan for bringing your brother. You just grab him by the hand off you go to the movies. That's actually a demo, an explanation I got from my mom. She's in her 80s. She thought this analogy was pretty good years ago when I came up with it. All right, so let's create this index. It'll take roughly the same amount of time, so 30 seconds-ish. I could do the old, how many databases do you have while we wait? But what's your oldest version of SQL? Let's do that. What's the oldest version of SQL Server you're actually running? Ooh, great question just came in. Do file groups improve performance? Yes. Or are they not that significant nowadays storage capabilities? If you have SSDs all over the place and you have the ability to put a file group on a different actual set of hardware or at least different controllers to that separate, then it can benefit you. that gives you basically double the quote unquote spinning disk, even though they're not spinning, but the spindle power. But the multiple controllers going to the drives is the biggest bottleneck on a lot of systems, especially if you're running VMware, because that defaults to one virtual storage controller for your VM versus I think up to four it can have. If you can have four pathways to your drives, get them. Talk to your VMware guy. But yeah, it can. You have to lay it out properly and make sure that you put your whatever you want. Your two busiest, biggest tables might want to be on different ones for throughput. Your indexes on one. Some people put archive data on a separate file group and move that out of their active tables. So when they are doing stats maintenance and things like that, they're working on smaller subsets of table, 1 year versus 20 years, that kind of thing. There's a variety of ways to do it. It's largely size dependent. I mean, if you're running a 20 gig database, probably not going to help you any. 20 terabytes, there's definitely conversations to be had around that. But if you're doing all of it on the same drive and the same controller, no, you're not going to see any benefit really. All right, this is done. Let's scroll down here. Same query, and it's going to behave a little bit better. Still got 4 pages, and it's gone. So now that we've got an index that has all 3 of them in it, great. That's what we expected, I assume. Why did I say, but what if? The what if. Look what just changed. I got a where clause in there. It was on display name. Now it's on location. Okay, 10 seconds. What do you think is going to happen when I run this? Let me know if anybody got it. Look at those page reads. That's a lot more than 8. Well, it's a whole lot more than 4. And why did it do that? Because location is an include, and I stuck it in the where clause. Your where and joins are your best candidates for what needs to go in the key columns, not the includes, where I believe where is the most important, which is your equality and inequality. I know somebody asked about that when they signed up. Equality first, then inequality, then other things. Just call it that and make it reasonable. The 1 equals 1 doesn't do anything here other than give me 2, be able to do this and kind of turn things on and off for those of you that have not seen that syntax. But this had to go through, it found an index that had location in it and it scanned it to find the things, and then it found me, and then it gave us these results. So it didn't go back to the clustered index or the base table, the user's table, and scan that. So we got a little bit of advantage, and that's why the cost of it was 100 instead of 440 or whatever that the full table scans were doing earlier. But it still was a lot. And time stats, elapsed time, it says 1 second. I'm not sure about it. Yeah, it was pretty quick. Multiply by a million times an hour or whatever. That's a lot. Maybe a million's a bit too much. But it's because if this had been in the where clause, it would have worked just fine. So, well, what if we just make an index on just location? Can we do that? Of course we can do that. We're sysadmins. We have God rights. We can do anything we want to, right? Be careful with those sysadmin rights, kids. And just please disable your SA accounts and make a different one called, like, printer. Let that be your SA account. The hackers will never think printer has any rights. Yes, I've done that. All right. Logical reads. Created the index. Fine. Don't really care about the stats and the execution plan on an index create. So let's see what happens here. We have an index on location. We have an index on display name and reputation. I'm not going to give you time to guess because it's going to go so quickly. 49. That is so much better. Execution plan. It went to location. Remember this NC location index that we just created? It has ID in the background. And it went to the ID here and found my name to give me these results because these were already there. There I am. It didn't use the display name reputation index because it didn't need to. It was faster to go here, or so the optimizer decided. I'm fine with it. I don't care how it gets there as long as it gets there fast. Estimated cost 0.17. That's not bad at all for joining two things together at all. I love things that are under 1. I love it. That makes me super happy because this was probably a 27 cost query when I got handed it by a manager, which of course didn't happen. Well, let's put both of these things in the where clause. See what happens now. So now I'm just getting tricky and starting to look like real queries that happen in the real world. 4. Went straight into the display one. It went to the key column, found Kevin 3NF, and then grabbed the out of the includes, it grabbed a location there, even though it was in the where clause. This is the optimizer being way, way smarter than it was 4 or 5 versions ago. In SQL 2012, this thing would have just thrown barf all over the screen and said, no, I don't know what to do. But the optimizer and the engine are getting much, much, much better. This is, what am I running here? 2019? This is a 2022. How about that? So this whole system you're seeing was built up for some other purpose. But okay, we're going to kill off a couple things here. We're just going to straight up drop them. I said I don't do that, but it's my box. I can do whatever I want, right? Now let's run this thing and see what happens. It went and used a different index because I had a third one that had location in it, the one that had includes at the end right here. It found an index that worked rather than going to the table. And that is such a wonderful aspect of what the optimizer does. It does everything it can not have to scan the table or even go to the base table. Hang on a second. Let me get rid of the spam caller. Go away. Thank you. All right. That's it. That's what includes are for. Let's see if this is still fresh or not. All the queries I've been running can be satisfied with this one because it's got all the fields that we've been talking about. Now, again, somebody adds a field, suddenly you get a bunch of key lookups. That's what you're going to be looking for is what happened? Why is this query here? Why is this field here that didn't used to be? And which indexes should I adjust? If I had the NC display name reputation, and the display name reputation location, all 3 indexes, I would take the biggest one of those 3 if they had enough traffic to justify it, and that's the one I keep. I eliminate the storage requirements and the maintenance requirements of the other 2. And when I say maintenance, I generally mean stats these days, not rebuilding and reorganizing, because I just don't do that very often. If I have to on a system, it's like once a week, maybe at most. And then only the most fragmented stuff when there's space issues and memory issues and all that. But yeah, SQL Server is going to tell you, make me these 6 indexes, even though you've already got one that's covering all 6 of those, that different queries can, and the different queries are using the one that you've already got. SQL Server will lie to you in this area. It doesn't look out to see if those need to be done, or even when the query runs, it doesn't look at what ran and what index it may have used. It just makes you a recommendation. So please don't go off and just run those willy-nilly. You're going to wind up with 100 indexes on your table and massive data bloat and everything else. All right, I'm running a little bit longer than I thought I probably would, but that's all right. Let's wrap it up. Unused indexes are a performance killer. If you've got a 1,000,000 row table, which is relatively small, and it's getting, hundreds of thousands of updates every day, not inserts, but updates, the indexes that have the updated columns are also going to get updated. If they're getting read once every 3 days, get rid of them, because all that traffic's going through your transaction logs. It's going through your memory, your backups, your CPUs. I don't know, if what you're doing to them, if they're going to go parallel or whatever. But certain things in this area are parallel, some are single serial, but they're resource killers. I go through and whack unused indexes. If it hasn't been used in 30 days, it's gone. If it's been used 5 times, it's gone. But make sure you've got enough uptime to know. Because the caveat to this is the CEO's pet report that he runs whenever he feels like it goes too slow. Guess who he's yelling at? The guy at the bottom of the food chain, and that's DBA. Unless you got a junior DBA reporting to you, it's you. Be careful with what you do. Disable so you can rebuild quickly enough. Check things and test before you do any of it, but know that unused ones are a problem. Duplicates are a problem. Be careful, because if an index hint is there, queries can fail. Be careful around indexes. There's a number. Ozar loves to talk about the 5 and 5 number because he's got 5 fingers on each hand. 10 indexes might be the right number for one table. 3 is too many for another table. Totally dependent on your environment and your testing to prove out. And this is a thing in your test environment. You don't need production load on it. You can change an index around and see in the execution plans, like I've been showing you for the last hour, the difference with different types of indexes, and whichever one works out to be the best, That's the one you look at moving to prod. No, there's my 5 and 5 thing. I knew it was in here somewhere. That's kind of a joke for him. It's just a starting point. It might be less, it might be more. Um, Go back and check your indexes. If nothing else is going on, look at them every 3 months. That's my rule of thumb because I have thumbs. Um, some customers, I'm looking for unused indexes every week because they change their stuff a lot. Generally, every 1 3 months, whatever. Don't wait a year to do it, especially if it's an application that is actively being developed and new things are coming in, new tables and whatnot. Test first. Don't at me when you blow up prod and somebody tells you you need to make a resume. That's on you. That's all I've got. Have you got any other questions that Jeff can shove into the Slack before we all depart? Hit him up in the chat. Actually, I'm going to go into the chat now as well. Okay. So do you have a basic checklist when index tuning for the first time on a service or on a server? Checklist? Yeah, I go through and I look. I think I just did it actually. I go through and I look for unused because those are usually the easiest ones to do something about and free up a lot of traffic. I look for duplicates that are very obvious, display name and display name, comma reputation. Get rid of the display name one after testing it. And then I go through the missing ones. I usually do one table at a time, and I look at all of those aspects of it. And then and if it's a heap, I look for things that might make sense for a clustered index, so SQL Server doesn't have to work as hard. When I can, I like for my clustered index to also be my primary key because that's the fastest thing that SQL Server can work with as far as joins and finding pages and all that. It has to go through extra gyrations behind the scene. So I look at one table at a time. The way I do it, I look at the missing index reports, whichever one has the highest value of how important it would be, that's the table I start with, not the specific index, or the highest traffic table, whichever thing will benefit the most people or the most queries. I never start with query tuning on a new server because that fixes one thing. I start outside in Windows things, SQL installation things, index things, query things, and because my clients need to get the most bang for their buck, so we do that from the outside in. Um, Robbie, how do I see the actual execution plan of a query that is running slow? You might be able to pull it out of something like what does Brent call his SP Blitz Who, but Atom Mechanics SP Who is active with the parameter that says something like show query plans, something like that. I forget what it's actually called. If you can run Who is active while it's running, you might be lucky enough to actually get the plan that's running. That plan might be an estimated one. The only way you're going to actually get an actual execution plan is to actually execute the query. If it's an update query, obviously you need to make sure you're doing this in a test environment or with a test data row or something like that. You don't want to run around and update the balance of my checking account in the middle of the day as a test. Please don't do that. But that's the only one. Everything else you're going to see, just about everything else is going to be all um, estimated ones. That's what I'm trying to say. I just answered a question from like half an hour ago because I hadn't scrolled. Um, all right, that's what I've got. Anything else? Find me on LinkedIn. Jump in and comment on one of my posts, whatever. Send me to a very limited degree. I'll respond to direct messages. I try to not do too much of that. I definitely don't do individual free consulting through LinkedIn messaging. That's that's impossible for me to keep up with, and I'll probably tell you the wrong things.